writing molecular orbitals involving the p orbitals. And like I said, remember the p orbitals can form both the sigma bond and the pi bond. And remember my video on the quantum numbers, I told you that the p orbitals is made up of three suborbitals, and that is the ps, py, and what? Pz. Now, when two p orbitals of two atoms combine, it is their suborbitals that combine. Look at what I'm saying. You have 2p here plus 2p here. Now, it is their suborbitals that combine. Their suborbital meaning that here, this one you have px, py, pz, right? Then plus px, py, and pz, right? So we want to get their molecular what? Orbitals, right? And so this one will go with this one, right? So let me call this one 1. So this one will come like this, goes with this. Let me call it 2. While this one will come and go with this. So let me call it 3, right? And so if you want to write it, remember this is 2. So this is our 2p plus our 2p orbital. So if you want to write it, this will now give you the bonding pair. This is XX. So you have the sigma 2px. Remember, immediately you write the bonding, you have to write the anti-bonding immediately. So you have anti-bonding sigma 2px, right? So this is for 1. The next thing is for y. Please, there is a very important thing for you to note here. Let me write it first so that you do then I will now explain. Now, the second one is now this one, this number 2, py to py, will now give you pi py and antibonding pi py. And then have the started? Yes. Under p orbitals, the 3 suborbitals is only one of them, which is the x, that form the sigma bond. The rest of the 2 form pi bond. Note it very well. Under p orbitals, we have 3 suborbitals, and those 3 suborbitals, it is only the s that form the sigma bond. Remember, we have done the writing the molecular orbitals involving the s orbital. It's only the s that form the pi bond, the sigma bond. The p and the z form the pi bond. So that is why I'm using pi. Then the next one is this, which is that of the z. The same thing happens here. This is pi pz, and then anti-bonding pi pz, right? I just wanted to write it separately because this now we have to combine it. Now the first thing you have to do, remember I said in the part 2 of my video under molecular orbitals that the anti-bonding has what? Higher what? Energy than the one that doesn't have that, the one that is not the anti-bonding. I already said that in my video. Endeavor to check it. Now, if I want to write this right now, this is not how we write it. We have to write it on one straight line. I want to write it on a single straight line. So all you have to do is this one is now. I'll write something again. Oh, yeah, please. This is X, so not like I saw it. It was like anti-bonding. So first you write this. We normally write it at the straight line. This is sigma px, right? You know, when we are at the s orbital, I said immediately write the bonding, write the anti-bonding. It doesn't work that way under p orbitals. That is the rule. That's why I'm taking it one step at a time for you to understand it. Under p orbitals, you have to write the bonding first, or before you now come and write the anti-bonding. And there's another thing that you must note it very well. Under the p orbitals, the anti-bonding, this anti-bonding px must end, will be at the end part. Look at what I'm saying. So if I want to arrange this thing now, I will arrange it like this. So this is pi py, pi pz. Now I've finished writing that of the bonding molecular orbital. I want to start writing the anti-bonding. Because I started with S does not mean you now start, okay, anti-bonding PS. No, this one is of the higher energy level. It will end last. So I will not pick any of these. I'll write this antibonding PZ, right? Antibonding PY, and I will not end it with sigma antibonding PX. The antibonding of the PX is always the one that ends last. Why? It is of the higher energy level. So this is it. So if you want to write the molecular orbital for 2p orbital, this is how it will end. Not like this. I wanted to just explain it. That's why I'm bringing it out like this. We normally write it under a straight form like this. When I continue by the next video, believe me, things will start getting easier for you. Now, I want you to know something. Do not panic. This course itself have a lot of rules. For some molecular orbital, there will be some changes which you may end up seeing in the other videos. I noticed something here. I did not put 2 and 2. I did not put 2 here, 2 here, because that should be 2 and the 2 orbital. Because I noticed I put 2 here, so there should be 2 here. There should be 2 here. There should be 2 here. There should be 2 here, and I ended it with 2 here. So all of them should be 2 because we're talking about they are the same degenerate orbitals. So please correct that in your notes. And that is all for this video. I'll meet you in the next video. Please endeavor to put that too. It was a simple mistake.